Hello everyone, myself Pallavi Sharma, lecturer EC in Thaper Polytechnic College, Patiala. I'm going to start course on digital electronic subjects for diploma students. Today my session topic is introduction. Introduction to digital electronics. Contents of these sessions are introduction to digital electronics, analog signals. What do you mean by digital signals? Difference between analog signal and digital signals. Concept of positive and negative logic. Application and advantages of digital signal over analog signals. Introduction to digital electronics. Digital electronics is a field of electronics involving the study of digital signals and engineering of devices that use or produce them. Digital electronics is the foundation of digital computers and most automated systems. Nowadays, we are using calculators, computers, watches, communication systems, etc. The operation of these is based on the principle of digital techniques, and these systems are referred as a digital systems. The term digital is derived from the way in which the computer performs operation by counting. Digital electronics involving circuits and systems in which only two states are possible and that are represented by voltage levels. Digital electronics deals with logic gates, basic gates like OR gate, AND gate, NOT gate, other gates, universal gates like NOR gate, NAND gate, so on. Combinational circuits, like it is a combination of basic gates, and sequential circuit, it is a combination of combinational circuit plus memory element. Counters, flip-flops, shift register, all are the parts of digital electronics. What do you mean by analog signal? Signal can be analog or digital. Analog signal is a continuous signal whose amplitude vary with the time. It is defined as a voltage or current whose size is proportional to quantity it represents. It has infinite set of possible values. Velocities, sound, temperature, pressure are the analog quantities. Concept of positive and negative logic. As shown in the figure, there are two discrete levels. These levels can be represented using low and high. As shown in the figure A, lower of two levels, that is 0 to 1, 0 to 1 has been designated as low level, logic low level, and higher, that is from 3.5 to 5, represent 1. Means if voltage, signal received with the voltage 0 to 1 represent logic 0. If signal received with voltage 3.5 to 5 volt, then it will represented as logic 1. This is known as positive logic systems. In contrast to this, in figure B, the higher of two levels means 3.5 to 5 volt. Voltage ranges from 3.5 to 5 volt has been designated as low level, and lower, that is from 0 to 1, represent logic 1 as a high level. The voltage level between 0 to 1 is considered as logic low, whereas the voltage level between 3.1 to 5 is considered as high in case of positive logic system. It means that we can use either of the logic system depend upon the circuit or design. It means we can use any of the logic systems. Both logic system can be used by the designers. Depending upon the requirement, they can use any of the Sharing this information. Positive and negative logic system in digital electronics. If it require logic 1 to operate, engineer may refer to this condition as positive. Digital input output devices use दानिश बोलेगा अच्छा Basically, there are two types of representation used in digital systems, the positive logic system and the negative logic representation. In positive logic, bit 1 represent logic high, bit 0 represent logic low. And high is represented by 3.5 to 5 volts and low is represented by 0 to 1 volt. Similarly, in nice negative logic representation, bit 1 represent logic low and bit 0 represent logic high. In terms of voltage level, bit 1 can be represented as 0 to 1 and bit 0 can be represented as 3.5 to 5. Next is the advantages and application of digital signals. There are many advantages of digital signals over analog signals, such as effect of distortion, noise, and interference is much less in digital signals as they are less affected because they are in square form or they have only two values, 0 and 1. Digital circuits are more reliable. Digital circuits are easy to design and cheaper than analog signals. Digital signals which are inherently compatible with computers have potential to be stored, retrieved, processed and manipulated. The hardware implementation in digital circuit is more flexible than analog. The occurrence of crosstalk is very rare in digital communication. Signal processing functions such as encryption and compression are employed in digital circuit to maintain the secrecy of the information. The probability of error occurrence is reduced by applying error detection and error correction technique in digital systems. After this session, you will be able to understand the concept of analog signals, digital signals, and their differences, concept of positive logic and negative logic, and advantages and applications of digital signals over analog signals. Thank you so much.